First is, my opinion is that, Kubeflow should have a loosely coupled microservice-based architecture. And that this is really the result of what we sort of see going on in the ML landscape. And one of the consequences of this is, if we have this loosely coupled microservice-based architecture, where, we have lots of different components that are independently authored by different folks, how do we go about creating a cohesive experience and platform for our users? And so I'm going to argue that I think pipelines and orchestration and metadata, they're going to create a strong incentive to define common patterns that different parts of the stack are going to adopt in order to get the benefits of being able to participate in more complex workflows or collect data and surface that in a uniform way. And so that's what I think will hopefully lead to a uniform experience. So here's the outline. I'm going to talk briefly about the ML landscape. Then I'm going to talk about, a little bit more detail about what I think the Kubeflow architecture looks like. And then, just summarize briefly with, some of the topics that I think we should continue to discuss at the summit. So this is one of the canonical slides from the Kubeflow decks. I think David first presented this at his KubeCon talk in 2017. And so the idea is that if you're building an ML product, this is the sort of workflow of development that you go through. So you start off doing data ingestion and transformation. Once you have your data prepared, then you train your model. Once you've trained your model, you go about deploying that model, somewhere. And then once you have your model deployed, you have to operate that model, collect logs, et cetera. And the key point of this slide was that for each of these phases of development, you have multiple choices, right? So, if you're training your model, you could potentially be using PyTorch, you could be using TensorFlow, you could be using XGBoost, right? And I think a great way to capture the breadth of that landscape and the set of options is this diagram from the Deep Learning Foundation, right? That sort of attempts to build a diagram of the ML landscape. And so the purpose of this diagram is they've basically chunked up different areas of machine learning into different sort of functional areas, right? So there's a box for classical machine learning, there's a box for deep learning, and then you have like boxes for data, ethics, et cetera. And for each of these boxes, you can sort of zoom in and they can show you all the different projects and options you have available to you, right? So if you looked at the classical machine learning box and you zoomed in, you can see you have this rich set of tools and libraries available to you. You can be using Spark MLlib to build your models. You could be using XGBoost. You could be using scikit-learns. If you're using deep learning, you have a whole rich set of choices in terms of the frameworks like PyTorch or TensorFlow. And then even then, once you've picked your framework, there's a whole set of libraries like Keras and TFX on top of these frameworks that you can potentially use, right? So the key takeaway here, I think, is if you're, from a Kubeflow perspective, is that when we look at the landscape is really broad and it's growing really rapidly, right? And, a key takeaway for this is that a lot of this innovation is happening outside of the Kubeflow community, and that's probably going to continue, right? So I think this trend is really what's sort of propelling us to, have a microservice-based architecture. Right. So the idea here is, the goal of Kubeflow is to provide a composable platform for machine learning. Right. And so the goal is to make it super easy for people to take advantage of these different components in the ML landscape. And so because of that, if we look at, the fact that the ML landscape is growing really broadly, we have to think about how we're going to design Kubeflow and architect Kubeflow so it's really easy to assimilate, new technologies and put them at the fingertips of our users. So, a simple example is, if we look at model servers, right, and we try to name the model servers off the top of your head, the ones that I can think of, OpenVINO, you have NVIDIA's inference server, we have TensorFlow serving, we have, just generic Flask apps, and then we have Seldon, right? So we have a very broad landscape of different servers that we want to be able to make available to our users, right? And so I think as a result of that, when we think about how we incorporate these model servers into our platform, I don't think we can afford to do a lot of deep and expensive integrations with a particular model server because that's not necessarily going to scale. So if you look at the architecture that we're trying to design, I think we want to design things in a way that it's really easy to incorporate a new model server. And so that's kind of the point of this slide. So this is kind of the architecture we're looking at with our 0.5 release, where we basically have a shared namespace in which we run all of the shared components of Kubeflow, right? So all of the custom controllers that are shared across different users are in this shared namespace. Web apps like the Notebook Manager UI that would be shared across users, those also run in this shared namespace. And then we give each user their own isolated namespace in which they can create their own resources and take advantage of RBAC and namespaces for permission isolation and also for resource isolation. And so the advantage of this sort of microservice-based architecture is that it's really easy to incorporate new technologies, right? So if somebody comes up with a new custom controller, we can simply deploy that in our shared namespace and make that available to those users. And we could take advantage of the same scaffolding that we've already built to do things like isolate users in different namespace and also set up ingress and authorization. So just to summarize, excuse me, some of our remote contributors. I think when you look at the landscape, the challenge that we're facing as a platform is, how do we scale? So our goal, which is pretty ambitious, is to put the entire ML landscape at the fingertips of our users, right? And so if you look at how quickly that landscape is growing, we have a scalability challenge, right? And so I think if you look at that landscape, we're not going to be able to sort of curate that landscape ourselves, right? So we have to really try to create incentives for people working outside of the Kubeflow community and work on those other projects to try to play well with Kubeflow. And so I think that's really the incentive for trying to drive a microservice architecture, is really to make it easy for those people to make their products and libraries and tools work well with us, right? And I think the way that we sort of incentivize them to do that is we provide scaffolding that makes it easy to run well on Kubernetes, right? So providing that, multi-user story, that isolation, handling things like, setting up authorization. And I think critical to that is it's really critical to make sure that we try to minimize the integration costs of integrating with Kubeflow, so we make it as simple as possible for people to make their apps play well with us. And then similarly, we want to create incentives for them to do so. As I mentioned, the multi-user story, so that they have an incentive to actually pay those integration costs and make their stuff work well with Kubeflow. And so the point of this diagram here is that we really want to try to get some network effects where we really where people look at Kubeflow, see our user base, and see that as an incentive to make their applications play well with Kubeflow. And then in turn, that brings more users to Kubeflow, which in turn encourages more application developers to make their apps play well with Kubeflow. So I think this creates a problem though, right? So if we have this loosely coupled microservice architecture where every sort of service or component in Kubeflow is developed independently, potentially by different developers at different companies, how are we going to go about creating a cohesive platform that has a unified experience across all the different layers, right? And so my contention is that orchestration and this desire to incorporate these components as part of more complex workflows will help drive the adoption of common patterns across the stack that will create a uniform experience. And similarly, the same will happen for metadata, right? So here's a diagram of one possible view of the architecture to try to make that point. So we can think of the the stack at the lowest level. We have APIs and services that are pretty low level in the sense that they're aimed at doing one particular function, right? So in this box we have all of our job operators that are really focused on doing a single thing, right? So we have a job operator for TensorFlow whose sole purpose is to do distributed training for TensorFlow, and we have similar operators for other frameworks. We also have operators developed outside of Kubeflow that perform other functions, right? So we have the Argo workflow controller, we have the Selden controller, we have the Spark job controller. And then above this layer, we have these systems, right? And these systems aim at combining multiple of these low-level services to provide more complete functionality for our users, right? So a big one would be Kubeflow pipelines, which attempts to combine a bunch of these low-level custom controllers, as well as some added functionality like a web UI to provide and a CLI to provide a complete user experience. Similarly, we have a bunch of services that comprise our notebook management solution, so people have a good story around notebooks, as well as hyperparameter tuning and CatTib, which combines multiple components. But each one of these systems is relatively independent. You can use pipelines without notebooks. You can use notebooks without pipelines. And you can use Katib without using either of those. And then at the top layer, we sort of have some end user facing command line tools and libraries. And one of the primary goal of these tools is to create a end user experience that's very data scientist friendly and hides some of the complexity of Kubernetes under the hood. But then what we have going along the side is, I think we have these verticals and these cross-cutting efforts. And the two that I can think of are orchestration and metadata, right? So, and these create an incentive to create patterns that are common across these different layers. And that's what creates sort of the unifying theme across the layers. Let me try to provide some more examples of why I think that's the case. So let's think about orchestration and pipelines, right? So if we look at pipelines, one particular component that we could think of is statistics gen. So this is one component in TFX, which is a library and framework for machine learning that is being built by the TFX team at Google. And so one component is statistics gen, which is a component that can be used to compute statistics about your data, right? And so you can use this component completely in its own in isolation. But in most cases, you probably want to use this as part of some larger complex ML workflow, right? So the diagram on the right is, I think it's the taxi cab example that they just published at the TF Dev Summit. The statistics gen is just one step in this pipeline. And the reason for that is if you're computing statistics about your data, you probably want to use these statistics, right? So maybe you want to use those statistics to pre-process your data or transform this data, or maybe you want to use those statistics as features in training your model. So if you want to take this component and incorporate that into a larger complex workflow, you need to define what your inputs are and what your outputs are so that this larger orchestration system like Kubeflow pipelines can pass data to that component and also take the outputs of that component and pass them to the next steps in the pipeline, right? So because of that, the orchestration layer is in a position to define certain patterns, let's say, for defining your inputs and outputs. And there's an incentive for component developers to adhere or adopt these patterns so their applications can be easily orchestrated into larger complex ML workflows. So here's one possible example of what a pattern would look like. This is mainly to provide an illustration. It's not necessarily to suggest this is a good pattern. But if we look at like our job operators, like our TensorFlow job operator, or just the Kubernetes Bash job operator, one of the problems we face is that there's no pattern or standard way to get output from that job, right? Because all that job is doing is running some arbitrary binary. So there's no standard or widely accepted way for specifying what the output of that step or binary was, right? So that's kind of a barrier to taking some arbitrary binary, wrapping that in a Kubernetes job and orchestrating that as part of some larger complex workflow where the outputs then get passed to the next step in the pipeline. So here's one possible way we could define a pattern that would enable that, right? So we can take advantage of Kubernetes resources, which allows us to specify arbitrary annotations on that resource. And we could attach some annotation which has named outputs. And in that outputs annotation, we could serialize some well-defined structured data protocol record, right? And as YAML or some other serialization, right? And then we could provide, let's say a library that would allow people to easily update that annotation from their code, so they could easily modify their code to report their outputs as the annotation, right? And the incentive for now doing this would be because if you adopt this pattern, you can now allow your step or your binary to easily be orchestrated as a part of a larger complex ML workflow. The other big one, I think, will be metadata. So I think the goal of metadata is we really want to understand how our models were produced and how they're being consumed, right? And so if you're trying to understand how your models are being produced, you need to collect data from a lot of different sources, right? So you're potentially using a notebook to transform your data or build your model. You could also be training your model using hyperparameter tuning like Katib, or running a TF job, or using pipelines, right? So all of those different systems could be doing important transformations of your data that are important to log if you want to understand how your models are being produced, right? And one of the problems right now, though, is there's really no standard way to sort of record information about how your job or binary was executed, what it did, right? So if you look at, let's say, a TF job or a Kubernetes bash job, there's lots of different patterns that people could adopt to encode information about what that execution is doing, right? So one example is people could use command line arguments, and those command line arguments could specify the inputs and outputs as well as the hyperparameters to use for training. But there's no standard set of input parameters that people use, right? Or naming conventions, for example. But people could also use environment variables. They could also use a config file that contains a protocol buffer that describes their training data or how they should train their model. And so that becomes a barrier to collecting this meta information in a standard way. So last week Zhengwei presented some ideas that he and AJ have been working on for some standard schemas for metadata, and one of those was like a run schema for tracking all the executions of the model. And the lack of common patterns for encoding this meta information prevents us from building tooling and automating the collection of this metadata. But suppose we defined a common pattern, and again, this is just meant as an illustration. It's not necessarily to suggest this is a good pattern. But again, suppose we took advantage of metadata annotations in Kubernetes, and we defined an annotation in there to encode these schemas that Zhengwei and AJ had proposed, right? So we can add an annotation in there that contains the run, named run, that contains the representation of the run schema that they've defined, right? So that then allows other layers in the stack to begin adopting this pattern. So for starters, we could build a logger that would automatically watch the Kubernetes API server and look for objects with this annotation, and then store this annotation in an appropriate metadata database so that information can then be surfaced to users, right? And so this then creates incentives for other components as part of the Kubeflow stack to begin adopting this pattern so that their users get this benefit as well. So as an example, the Selden custom controller for deploying models could try to start auto-populating that annotation based on the Selden spec, so that the users of the Selden deployment don't have to even think about specifying that annotation. And the incentive for doing that for Selden is that Selden's users would probably want to see this meta information about how their models are being consumed, being surfaced. Similarly, we could do this as well in the Fairing library, which is our our tooling library that we're building to make it easy to deploy and train models from a notebook. That could likewise take the information it knows about the model and bake that into the annotation, so that metadata could also be surfaced in the metadata system. So taking this, so that was a mouthful. But here are the takeaways that I hope we'll continue to discuss. So first, I'm clearly a strong proponent of a microservice-based architecture, but it is not the only option. So I think we should, continue to discuss this and look at, other competing architectures and, architectures that could be more monolithic. I think like I said, one of the problems that this creates is, how do we go about creating a unified experience across these different layers and these different common services that sort of are going to promote that unified experience. So I think that's a huge topic that we should continue to discuss. If you buy into this idea of the importance of defining common patterns that people can adopt across the stack, then I think we should talk about, what are the patterns that we're encouraging, and are they good patterns in sense of being lightweight, being friendly or natural to our users, who could both be, DevOps engineers who are familiar with Kubernetes, or data scientists who might be familiar with other slightly different patterns. So that's it. Thank you very much. Do I have time for questions?
One.